So on screen at the moment is just a recap we've put together of what we did last lesson. Most important bit, this bit down here, central limit theorem. X bar itself is a continuous random variable, normally distributed mu sigma squared over n. Doesn't matter what distribution x followed to start with. Last thing I think we did was an example, this one here, cubical dice. We drew its distribution, probability distribution, and we worked out its mean and its variance, and we then used the central limit theorem to find the distribution of x bar, and we worked out the probability that the sample mean was bigger than 3 was this value over here. And we didn't use the continuity correction because whilst x was discrete, x bar wasn't. That's what we've done so far. We are now moving on to a continuation of this example, which is part 2b, which I think you've probably already got written down on the handout. So part 2b starts off in the same example. Find the probability the total is greater than 120. So it's still example 2, but it's part B now, and that is find the probability that the total score, bracket shouldn't be there, total score is greater than 120. And just to recap what we had previously, we had x was a dice that either gave us 1, 3 or 6, and those probabilities were a half, a third and 1/6. This is what we had last time. And we have worked out already that the expected value of x, which is mu, is 2.5, and the variance of x we worked out to be 3 1/4. That's what we had last lesson. And we are rolling this dice 40 times, so it's got 40 rolls. I think that's all the information we need to do this next bit. So, did you have this bit of paper somewhere which said example 2b continued? Yeah. Okay, you've got that. Okay. So it's still the same example, it's continuing, but now we're looking at the total. So, last lesson we said that x bar followed the normal distribution. What I'm telling you now is if you add up lots of x's, they here also will follow the normal distribution. Totals would also follow the normal distribution. So sums of x's follow the normal distribution. I'm just going to write it down again. We had n being 40. So the sum of x will follow the normal distribution. What we've got to work out now is what goes in here. We know that on each throw of the dice we're expecting, on average, to get 2.5. That's our population mean, that's our expected value of x. We are rolling this dice 40 times. What do you think we are expecting our total of 40 rolls
100
to be? Where did that come from?
2.5 times 40.
Yeah, it is 2.5 times by 40. Okay, that's right. So that is the single x, the expected value of x there, times by n. That is correct. That's just logical, that just makes sense. And if I write the mean down over here I got to write down the variance, and it is just the variance of x times by n that you do. And we've already said the variance of these scores is 3 1/4, so we do 3 1/4 times by 40. So the important bit on that line is actually what I've written really small, I suppose, really there. That if you're doing the sums of x's, it is normally distributed with the expected value times by n for the mean, and the variance times by n for the variance, for the sum. So if we've got our distribution, this question was asking us the probability that the sum of the scores, bring that bracket down again, we didn't want to, is greater than 120. And I now have my sum is distributed like this. What would be a good first move if you've got to do a probability that the sum of the x's is greater than 120?
Probability of sum 1 minus 1 minus probability is less than 120.
Yeah, okay. According to the Billy principle, I can put an extra bar there if I want to. Doesn't make any difference. So, can I just go straight into my phi-ing here?
Can you write sigma x?
If you wanted to put in there, you could have put sigma x. Yes, that would be fine. I think that's pretty clear what you're talking about. Yeah. Actually, you can't do what I just said.
Or do less than equal to?
Well, wait, this bit's fine, but the next bit I said, can you just go straight into the phi-ing and do that?
Right.
It's one other thing you've got to do here.
Continuity curve.
Why?
I thought you said you couldn't do it though. You didn't have
That
to
was
do
with
it.
the mean. With x bar can be a decimal, it can be an average, because it's an average of the means.
Because discrete. It's not
Yeah,
continuous.
this is just a total of discrete numbers, so it itself will be discrete. So the key thing here is, as the sum, or sigma x if you want to call it like that, is discrete, because you are adding up loads of discrete things, it is discrete, so you do need the continuity correction. So you don't need the continuity correction for x bar, but you do need it for the sum of x values. So what I'm going to do now is just put here a little n. No, I'm not going to do that actually, because I'm not doing that at all. Not doing that. I just need to rewrite this with the continuity correction in here. So, this is where we need to be really careful. I was looking before for greater than 120. Now this is where I actually do need to make sure I get this right. Greater than 120 is less than or equal to 120. So what value am I going to use in here?
Does it have to be whole numbers because it's a dice?
The score will be, yes.
So
what I'm saying in here, am I going to put in here 119 and a half or 120 and a half?
100 on the other.
120 now. How confident are you of that?
100%.
You're correct.
Even though it's
Okay.
impossible to get half,
Yes.
you roll the dice.
Yes.
Okay.
Because we've had to include 120 here when we turned it round. The only way you can include 120 is if we go up to 120 and a half. So actually when I said here it doesn't matter whether we put that bar on, and this one it does really. And that is the correct thing that we have to do here. And now we can just do our sort of normal probability stuff. That's 1 minus phi of x minus mu. Now we said earlier on, if I can just concertina that, mu is this now. This is our mean. We didn't actually work it out up here, although Chelsea did tell us at the time that was 100. Maybe we can arrow that was 100.
Now, is that one on the right, the 3?
This one over here.
Is that squared? Is that already
That is
squared?
sigma squared there, yes. Okay.
So you have to
I need to
square.
work that out and then square root that. Can anybody tell me what 3 1/4 of 40 is? Because I haven't
Root
got.
130.
Sorry?
Root 130.
Root 130. So that's 130 there. So down here it's root 130. Okay. So I'll pull those lines apart again so we've got everything there. Then it's a case of working out the value of the bracket, doing the phi of it, doing the 1 minus it. I'm going to freeze things there for a minute.
I think this one was actually.
Okay, if you're following us on the video, you can see the answers there. I'm just going to stop the video at this point.